Right, Jivraj, you're still on the call?
Yes, but I'm not
You,
able to access internet through my laptop.
okay, no problem. You have an update for us on the GA6, just quickly?
Let me check if it is updated. I
No, no, I
haven't
mean
received
it's
any mail, so
okay. What? No, what did they last inform you specifically about GA6? You're not audible.
uh, so we informed them to do the changes in the second and third question and the seventh question.
Yeah, and the from our end everything is done, right?
Yes,
Okay. Can you can
Jason has
you
been updated.
okay? Can you message Narayanan just to make sure he has pushed it?
Okay,
Okay.
I'm doing that.
Okay. Cool. Thanks, Jivraj. Okay. So the other thing, Jivraj, if you can, at some point early on, we will just demo the UV part of it as well, so that students are aware how that works. So whenever you're ready, just let us know, and then we can demonstrate the UV part. Okay, so good evening, everyone. Welcome to TDS Thursday session on 5th December. And today we'll be going extensively through the ins and outs of Project 2. This is a project that has never been done before in TDS. And also, as Anand has pointed out, something most people have not done, even those who are very experienced with writing code and things of that sort. So it's fairly innovative. We worked on it on producing a workflow for it, and it was pretty fantastic actually. And we were just absolutely blown away by what we are able to do today with the tools that we have. So that's what we'll be exploring. And let me share my screen. And let's see here, discourse. Okay, so basic points about it is you have to write an LLM based application, okay, that analyzes a data set. You have to convince the LLM that your code and output are good. Now this second bit, I'm not going to touch too much upon, but what we will show you today is how to write an LLM based program that analyzes a data set. Okay, this is the hard bit. This bit is you'll have to play around to get things to work out. Okay, so it's a bit like how you were trying to convince the LLM to say yes. Yeah, so but compared to that, this probably is easier. Unless you were lucky with that question in our.
Sir,
Yeah.
convince to us what the meaning of that.
So what will happen is, like nobody likes to do reviews, right? So in project one, we gave clear rubrics to students, and still 1/3 of the repos did not get reviews, which is why there's been such a delay in pushing out the score, right? So how do we get rid of the human element? Well, we'll just now have an LLM evaluate you. So that's how we are going to do it.
Okay, sir.
So this project, that's what will happen. It will replace people who are reviewing, and instead an LLM will review it. But the
So the
trick is,
LLM that we have to convince, that is mentioned in point 2, is the LLM that you are going to use to evaluate.
Hmm. Based on
um,
our instruction.
yeah. So the LLM will be from our end.
Yeah.
So
So the second point is actually, it means that write the code in such a way that the LLM will be convinced to score it according to the scoring board.
yes, yeah,
It's not going to be evaluated by a human.
correct.
Okay.
And this this is a very true thing, right? Start early, because we put in a lot of effort to make just a working workflow for you guys that which we'll be demonstrating today. So don't take this lightly. But having said that, it's a very fun project. This is, in fact, I would say the most fun project I've done in a long time. So it's a really nice project. So the main project is of course on this page over here. Again, it says the same thing over here. Now, in terms of the workflow, so you have to create, first of all, this file called autolysis.py. Okay.
Autolysis.
Or yeah, autolysis, or however you want to pronounce it. So don't make any deviations from what is described here. Okay. One of the big problems in project one, for example, was people didn't read the instructions and didn't follow it carefully. Just go line by line and make sure you're doing exactly what's been asked. Okay. So the file should be exactly this. It should be submitted in via Git repository. The Python script that you're writing, this script should run by using this command. Okay. So UV run, we did try it out ourselves. It's actually pretty fantastic. It's very easy to do. I don't have a working model immediately on this machine that I'm using to show you today. By the way, my screen is visible, right? I just want to make sure.
Yes, it is.
Okay.
Yes, sir, it
So,
is.
yeah. So it's very straightforward. It's not very difficult. So that's why Jivraj will show you, because he has it installed on his machine somewhere. And but for now, we will not worry about this bit. Okay. The UV run part we'll not worry about. The important thing is you get your autolysis, get working on this, because this will take a lot of effort. And the main thing is it has to take an argument from the command line, and that argument will be the dataset.csv. Okay. This file name may vary. Okay, it doesn't necessarily have to be exactly this name. So make sure when you're parameterizing your arguments that you take it in as a variable and process it accordingly. Okay, so just keep that in mind. It doesn't mean that this is the name of the file that will be given. Okay. What should this produce? What should your Python file produce? So that's what's given here. After you give this input, your Python file should produce a single markdown file called readme.md. So just like when you say Python run, it produces something, right? Sometimes it gives you a prompt or what. Here, there's not going to be any prompts. There's going to be no human involvement at all. The whole point of this is it's completely automated from start to finish. All it does is you run this and it should pop out with readme.md. Okay. And what does readme.md should have? It should have some automated analysis written as a story. What this means, we'll explain a bit later. But basically, it means that, let's say you're given some data set. So there are some example data sets. You're given a data set of books. Maybe there are some analysis done on the genres of books. Maybe certain genre, people who read certain genres. So say, for example, people who like horror also like biographies or something. I'm just making this up. Okay. So that's what your analysis found out, right? So that would be sort of things that would appear in your readme.md file. Analysis about your files, about the data set that's been given. The next thing to remember is the data set can be anything, but it will always be a CSV file. So in other words, it will always be tabular information. These are just examples. Okay, Goodreads, happiness, CSV. That doesn't mean we are going to evaluate on these specifically. What it means is these are the kind of data sets that you can test your autolysis spy on. Okay, but you can also test it on other things. And in today's session, we will not use these. Okay, these you can use yourself. We will show you with another data set so that you get an idea that your file should actually run with any kind of data set that is thrown at it, as long as it's in tabular form and in a CSV package. So that's about the markdown file. The second thing is it should also produce some charts that support the story you're trying to tell. Okay, so that's what the autolysis or autolysis Python file should produce: a README and some charts. It suggested 1 to 3 charts. That's because one thing that Anand has to do when he's running his script on his end, he will also have to give the LLM some rubrics to evaluate your file, and all those take up tokens along with the size of your file, right? So your file could be pretty big, your images will take up tokens, all these things will take, the data set will take up tokens. So when all these are put together, plus his evaluation script, it will take up a lot of tokens, right? So that's why don't put too many, don't make your autolysis file generate like 50 PNGs or something, okay? Even though it might be cool. Less is more, as they say, right? Try to give the most meaningful, fantastic analysis in a few charts, okay? So
Less
those are the
and
two.
meaning charts.
Yeah. So don't make simplistic ones, okay? That will not be, I mean, you will get marks, but try and be innovative, try
Some
and
more
make,
interesting.
yeah, some interesting analysis should be there, right? So get the LLM to get you some interesting analysis. So that's the output, okay? Next thing, create, yeah, okay. This is also important. So far throughout this subject, we have always been using Jupyter notebooks or Google Colab, right? Now you have to create a single PY file. So in other words, you shouldn't have lots of other scripts coming in. You shouldn't load scripts from other places. So sometimes in Python, you can load a project, right? And in a project, there'll be multiple files. And there will be a one starting file, and then lots of files get imported into it. You don't want that. Everything has to be in a single file. So, and in this case, it will be that autolysis file. So just remember that. That's very important. Second thing is you have to use your token. I hope all of you know how to use that. You can get it at this link over here, and they have increased the limit to $2. It might seem very less, but Jivraj and I hammered the LLM a lot when making our working model for this session, and we ended up using only 8 cents. Okay, so yeah, it's a big limit you have been given. If you are clever about it and do it in a systematic, professional, intelligent way, then you should. I'd be surprised if you hit that limit. But maybe some of you guys come up with some very interesting, and I'm looking forward to seeing your projects. Maybe you'll come up with something truly fun to see and for us to learn from, because
So
even we are learning.
during the creation of scripting, we
Yeah.
have we have to test many things. In
Yes.
that case, we cross the limit. Sir, then how can we handle that things
Yeah.
to put
Just inform us.
all the Python script in a one single file? Because
Yeah. Yeah.
we run that, they run all the functions.
Yeah. So I'm going to show how you can do that today. Okay. I know I've said create only one file, but that, remember, is for your final submission. But when we are working on this file, we will actually work on it in bits and pieces. We'll work on it in segments rather than working on it as a whole. Okay. But I'll come to that. I'll just go over this main page first. So yeah, and if you run out of the limit, you can get some more, but of course, he says to try and avoid that. And like I said, in our session today, we'll show how you can avoid hitting that limit by if you follow the techniques we use. Okay. Don't commit the token in your repository because someone will almost certainly steal it. Okay. Public repositories can get scraped by bots. And if there's anything like a proxy token or any kind of key, you better believe it, someone is going to steal it. Okay, the public repository is like keeping it on the public road. Okay, so don't put your AI token in there, and I'll show you how to keep your structure your program.
Hide them.
So yeah, so that you can deal with it. Stick to 4.0 mini, GPT 4.0 mini, so that I'll show you as well. Then again, here's an important bit. It should be like super bold and big. Your script should work with any valid CSV file. Okay, you don't know in advance what the data looks like, so don't make assumptions. Do generic. That's why we are not going to use these files today. We will show you with some other files, so that way you will understand that how to create a program that is intelligent and can evaluate any CSV. Okay.
So, sir, we have not fixed CSV file. So how we find any interesting analysis on
Yeah,
that
yeah.
thing?
I
We
will
have
show
to
you.
convince the LLM to find that insight on
Yes.
that data set.
Yes.
That is a
So
big deal.
yeah, yeah. It's today is going to be amazing. Today's session is going to be amazing. So don't worry. We'll show you.
Okay, sir.
Okay. Ask the so yeah, this is the second part of it. Ask the LLM, all that sort of thing. So this I will demonstrate, so I won't go through it too much. And then gives you some suggestions. You know, you can ask the LLM to generate code, ask the LLM to generate summaries, ask the LLM use function calls while using the LLM, and then there's some links over there. So we'll show you all that. And these are some ideas. Okay, you don't have to do all of these, or you don't have to do any of these. You can do whatever you want, but these are just some general ideas that you can do in
Guidance.
terms of some guidance. That's good word. Then some important considerations when you are hitting the API. Don't send the entire data set. Okay, first of all, LLMs are hopeless at math, so instead send summaries and maybe little bits of data set, and we'll show you how to do that.
Sir,
Uh,
first once again, sir. First point, sir. Don't
yeah,
send the entire data set to LLM.
yeah. What about it? What's the question?
Sir, I did not understand, sir.
Okay,
Yes.
so you typically in a CSV file, you will have like thousands of rows, right, of information. So instead of
Hmm.
sending thousands of rows, just send it 5 or 10 rows,
Okay.
right? That's enough to make an analysis on, right?
Hmm. Okay.
So it will give you some suggestions. Then in your code, you will have to run an analysis on it,
Hmm.
right? So again, like I said, I'll show you the workflow. Then visualize. Okay, so create a chart basically. It says here we suggest use Seaborn. We do not actually stick to this recommendation because in our own personal testing that we did, we found that the LLM is very bad at using Seaborn for some reason. I think it's not been trained on Seaborn, so it doesn't know how to use it very well. So when we show you a working model today, we'll show you that it doesn't really matter. So don't worry about this too much. The next thing is get creative, export. So this is important as well. All your charts have to be PNG. Okay, don't put JPEG or something else and then cry that, oh, I didn't get marks or something. It's written here, right? Do this. And yeah, the reason for not sending the entire analysis is, you might run out of tokens. Only send things that are important. And again, we'll show you how to do this. Narrating the story, okay, that's fine. Then there's just some further details. Now I'm going over this quickly because these are all details, but you should read through this. If you don't understand any of this, just message us or ask us, and we will give you
Sir,
clarification.
go to the above, sir.
Yeah.
Yes, sir. Don't send the entire analysis to the LLM. We
Yeah.
have to analysis, auto analysis by the help of LLM.
Yes.
And you also told that don't send the entire analysis to the LLM.
Yeah. So I will explain that when we do the project.
Okay.
Right. So when I show you the workflow today, you will understand once we start doing that. So to give you an idea, okay. So what happens is, when you open a GPT window, like when you open a GPT window like this, right? What happens? And by the way, if you didn't know, all of you have access to this virtual GPT TA. for TDS. It has been trained on TDS data, so you can use this and try it out if you want to.
We didn't know how do you access it?
Yes, sir.
There's a discourse post on it with the it was introduced last term.
We can search it there also, there itself,
Yeah.
ChatGPT.
So yeah, so it was this post over here, Dawn of the Virtual PA. Okay, so it's a GPT that we have created for TDS specifically. It's been trained on our TDS modules, and so it has got that library information in there. It's been trained on our videos that we have put out, not the TA videos, the lecture videos, and things like that. So it's been updated, I think, at the end of last term as well. So it's
So we have to download that.
sorry.
We have to download this.
No, you don't have to download it. It's a GPT. You just go to this link and it will open it up. It's the IITM Tools for Data Science Teaching Assistant,
Okay.
and it guides students with
Can you
specifically
provide
TDS.
this, sir?
Yeah, I'll give you the link for it. Okay.
Thanks.
Pin that there. So anyway, that's an aside. Where were we? Oh yeah, okay. So the thing with GPT, right? That is this kind of GPT. When you type in here, it actually has a memory of what you're sending it. So as you continue the conversation, it keeps on remembering the things you've sent it before and continues to answer within context. So this is what's called the context window. Okay. The problem with an API, okay, this is not an API. Okay, this is using their application itself. Okay, the browser application. The problem with the API is every time you send a message, it has no memory of the message you sent previously. In other words, it has no context. So each message is as if you're starting a brand new conversation. So it's like someone who has amnesia, right? You speak to him for a minute, and then immediately, like, you ask him something else, and then it's like having a brand new conversation with someone you've never met before. So that's the limitation of the using GPT API calls. So the way to get around that is you have to provide some information of what you've sent before and what you want to talk about now in the API call. Okay. So when that happens, you as your program progresses, your context keeps getting bigger and bigger, and that's why this note has been put here. Don't send the entire analysis. So there will be an appropriate point where you'll have to send enough information versus not enough information. So we'll show you how to kind of balance that aspect of it. So we'll show you a working example of this. Okay, how to work with that. So that's why this has been written here. So remember, that's a limitation of API calls to an LLM or to OpenAI in that matter, and most major LLMs out there. They don't have a context window. But if you use their browser, then it has a context window. Or if you use their app, then they have a context window. But in an API call, they don't have context window. So just remember that. It's an important limitation. And so you'll have to think about that when you're writing your program. Okay, right. So these are all about the insights. Images small, again, for the reason for tokens. Autolysis. Okay. So submit, you have to create a repository. Now remember, follow these instructions exactly. Okay, if it says created with an MIT license, don't make a GNU license, or don't make some other license. Just do exactly what it says. Okay, create these directories. Okay, this is required. They want you to run your tests on these three scripts. The outputs of those have to come into these folders. So each of these folders will have a README and a PNG and some PNG files. Okay, so that's the output. The output of your autolysis should go into these three according to the data set. But don't commit the input CSVs, just the README and the PNGs. Okay, commit and push these. Then what else? Right. So yeah. Okay. And this is the important bit. Submit it to this form. Okay. You'll push all that, and then you'll. If you don't do this bit, you'll not get any score. Right. So remember to fill this form. And then it talks about how it's evaluated. So this I'll leave you to read. It just tells you how the evaluation is done. Try to fulfill all these requirements, and then you will get all the marks. Something to keep in mind, it's out of 20, the total, okay? But if you add up all these, it's more than 20, but that's because there is a huge bonus here of 12 marks.
Bonus
So,
of 12 marks.
yes, okay. Now the reason for that is, this is a hard project. So many of you might copy paste from each other, okay? So we're giving 8 points for uniqueness, okay?
Uniqueness.
Yeah, and 4 marks for making it interesting. So if you all copy and paste, there won't be uniqueness, right? It'll all be very similar, and we will use an LLM to evaluate that. We'll do code embedding similarity and something similar to that, and it will give us a direct score that will tell us if it's similar or not. So it's kind of like a plagiarism check almost, but it's not a plagiarism check because there is no plagiarism in TDS. But it's just something to get you motivated to, do something original. Okay. Prompt injection is fine. Normalization. Okay. Deadline. Remember the
The
deadline.
normalizations are clearly adding all up one to
Yeah.
the 20.
So your ultimate marks will be out of 20. So let's say in your project you only score 8 marks, but you manage to get like 12 bonus marks, you'll still get 20, right?
If I get a total of both 20 and 12
Yeah,
bonus.
you'll still get 20. It's limited to 20.
Okay.
See, if we didn't have this bonus marks, right? Then any marks you lose here, you have no scope of gaining it back, right?
Okay.
If you think of a GA, right? When you write a GA, if you write 6 correct, 4 wrong, you have no scope of recovering those 4 marks, right?
Yes, sir. Yes.
So that's what the bonus is. The bonus is to give you some scope, even if you don't fulfill all, because these are a lot of requirements, right?
Yes. If I get 8 project marks and 12 bonus, then
you'll still get 20, because we'll be impressed with what? We'll be impressed with the fact that you wrote something original. We'll be impressed with the fact that you've done something very interesting, right? So that's what it is.
Okay.
The prompt injection is for the analysis part or the evaluation part?
I'm not exactly sure what this is, but we'll not worry about this too much at the moment, because I'm going to show you a working flow of how to create the project. I'll clarify what this means. Okay, I myself am not entirely sure what this means. Deadline, reading materials. Okay, yeah, watch these videos; they're useful. The seaborn, it depends. Okay, you might find it useful if you hard code the creation of graphs. Actually, seaborn is very easy to use. I think it's much easier than matplotlib. So if you're coding your project using seaborn, then that's great. Actually, it's very easy to use. So I recommend watching this video and even going through some of the tutorials there. Okay. So any questions so far before we start the main course, as it were?
No, sir.
Okay. All right. So now
I have a read about UV, sir. UV.
Yeah. When Jivraj is ready, is he on the call? Jivraj, are you able to demonstrate UV? Okay, anyway, don't worry about UV too much. If not today, then we'll show it on Sunday or something. Okay, it's the
Okay, sir.
last step basically. All you have to do is put you have to put a code block on the top of your code, your Python file, and you have to install UV. And once you do those two things, it will be able to, from the command line, run where is it? From the command line, then you'll be able to do this. Okay, and the reason we
Okay, sir.
want it to be compatible with UV is because this is what we'll be using to evaluate your script and sending various sorts of data sets. Okay, so that's why we have this requirement. There is some information here to read how to do it. And the useful bit is the second link. You see, it says here inline your dependencies. This is the useful link actually, because this is what you have to do. If this is your autolysis.py, at the very top of your autolysis file, you have to put this dependency is equal to and put a list. And these bits are important. If you miss this bit, right, it won't work. Okay, so make sure that you got this and this, and then you have to put a variable called dependencies equal to, and it's a list, and inside there you put your dependencies. So for example, here we have these dependencies. We got pandas, we got requests. You won't need this for the submission that you will be doing, but these two things will be required. Okay, so these are dependencies. Why are they called dependencies? They come from outside your project and they are required for your project to work, right? So that's why they're called dependencies. So that's something to be aware of. And what UV does is it automatically creates a virtual environment. It automatically gets the dependencies and then runs your project all in one go. And it does it way faster than anything we used to do before. So that's what it is. And so you put here, so here you'll put pandas, you'll put requests or seaborn or anything else that you would normally,
Matplotlib.
yeah, anything that you would normally say pip.install, you would put it here. Okay, so that's something to keep in mind. Right. Now, okay, so opened a Jupyter notebook. That's because initially the best way to work on the project is to work at it in bits and pieces. So get different functioning blocks together, and then once each of those pieces are working well, then you can join them all up in a single file. So that's what we're going to do here, and I'll show you that this actually does work. So I've got these three items. So initially it's just set up. The reason I've done this, so this will not be in your Python file, okay, because this is only for this particular local environment. So when you're doing the combined Python file, you won't require this. So the reason I have these functions and this dependency is because I have my AI proxy key in this file here called .env, and I want to get it out of the environment. So this function load .env mimics variable being loaded in your environment, in your shell environment. So then I can run this command, and as you notice, it thinks it's in the shell environment. Okay, it thinks that it is actually existing there, but it doesn't. I've simulated that by putting it in this file and using this bit of code here. So you will not have this, and you will not have this .env when you commit to GitHub. Okay, don't put this file there. Don't put this in GitHub. But starting from here, right, this is what you will require. So if
We
you
have to
remember on,
it will be available on that AI proxy token. We have to
yeah,
query that a proxy token from that environment.
yes, because we will be running your code, right? So
Yeah,
we will have our own token. Our token
we,
will be called this. This is what our token will be called.
You provide that token.
Yeah, we will provide the token from our environment, right? But
Yes.
your file has to pick it up.
Mhm.
So we are giving you the name of it. The name is AI proxy token. So you
You
have
fix
to
that.
run.
You fix that key
Yes,
value.
correct. So you have to run this code in your Python file. Okay,
Okay.
it has to be there. Otherwise, your code will not run. Okay, that's
So
the
in
first
other
important
words,
bit.
if we do the same way like this, we can
Yeah,
add this dot environment file to git ignore, right? Without committing.
yeah, yeah. .env you can run, add to git ignore. Yes,
Yeah, that is also an option.
yeah. But in case you're not very familiar with Git, that's why I said because some students are not very good with Git, right? So, but
Yeah.
yeah, you basically add it to .git ignore. But this is
Uh,
important, right? This should be there. Yeah, go
I
ahead.
have
Sorry.
one question.
Yeah,
Like if I'm working with this .env virtual
yeah,
environment,
yeah,
then where I should store my in my if I'm working in my local computer, where should
yeah.
I store that
Your proxy token.
proxy token? Correct.
Yeah, so that's what I've done here. I've stored it in this file called
Uh,
.env.
and in .env, where exactly? Like, is it any
It's
specific?
yeah, it's a text file. So it's I'll just create a text file here. So I'll call this my token or something.
Mhm.
Okay, so it will be called AI. So this is the name of the token, right? It has to be like this, and then you will get
So,
some long string, right? And it will be like this.
so that file name could be anything, and
No, no,
that
the file. No, no. If you're going to use this function, if you're
okay.
going to use this function, then you have to put it in a file called .env.
So the text file name should be anything, but that should be inside that.
No, no, no,
What?
no, no. The text file has to be named .env.
Okay. Okay.
See, the reason I'm not clicking on this is because if I click on this, I will make
Yeah.
my
Yeah.
key visible, right?
Yeah. Correct.
So
We know.
instead, I'm just showing you, pretend that this is .env.
Okay.
Inside .env, there will be a key and a value pair, right?
Correct.
And it will be exactly in this form. There should be no spaces between the equal to sign. So it shouldn't be like this, right? It will fail. It should be exactly like this.
Okay.
Yeah. And to load that from there, that's why I've got this bit of code.
Okay.
Okay. So now it mimics the fact that it's in your environment. And that's why I can run this code. Typically what happens is, if you don't have this, it will search in your actual local environment, this token.
Mhm.
But we have not exported it to the local environment. Instead, I've stored it in a file. And when I want it, I just load it over here.
Okay.
Okay.
Yeah.
So that's, but it has to be named .env. Okay. If you want more details of how this works, I've got it over here also. So this is the, I'll put this in the chat window so you have it available. So this is the library that I'm using for that. But remember, when you, this also is possible. You can export it into your environment. That also will work. But you just have to do this every time you restart your computer. Whereas in this case, you don't have to do that. So that's why I prefer it in a file. And the other thing is, when you're doing export, you'll have to get it from somewhere, right? That somewhere usually is going to be in a file anyway. So that's why this is good for one-time use, what Pradeep has shown, and this works just as well. Then you would not have to do what I've shown you. You would not have to put it in a
Also,
.env file.
also the export puts that value into the current environment, right? So when we
Correct.
run UV, in every run, it is going to create a new virtual environment and resolve the dependencies. So the environment changes from time to time, right? So it will
Yes.
not be, it will not be there. If we
Yeah.
add it as a line of code in our complete.py file itself, then how do we
Yeah.
commit it to Git again? So
Yeah. So yeah, don't see
that is
that.
not an option.
Yeah. So don't worry about how UV will run on our end. For it to run on our end is our problem, right? We need you to do this though, this bit over here. If you do this bit, UV will take care of the rest. So remember, once again, don't put this in, don't put this or don't put the .env file in your GitHub. Only put this in your GitHub. But while you're working on your local computer, you can keep this running, okay? This is just one way of doing it. There are many other ways to do it, like Pradeep has shown. Just export it and then just use this. Then you don't have to worry about these two things. I just showed this for convenience, okay? Is that clear?
Yes, sir.
Okay. Next things you will need, of course, is the API endpoint. I hope all of you are familiar with it by now, but just in case someone hasn't, go to the AI proxy place, get your token from here. If you go to this AI proxy, you will get the token, and then you will be able to get what you require. Then you need this URL to be able to run your program. And then you put that over here. The model is GPT-40-mini. And then we need some headers. So we'll do that now. So can someone tell me really quick how what headers we need when we are hitting the endpoint? Quick.
Application tab. No, sir.
Yeah. So it will be content, right?
Content.
Yeah,
Application type.
content.
Application JSON.
Yeah.
Authorization bearer and the key, sir.
Yes. Authorization, and it's an F string, and it'll be this token, right?
Yes, sir.
So those are the things we need. These are the basic elements that we need. Okay. And then the next part is we need to give it a data set. So I have to get the file. Just give me 1 second here. Okay, yeah. Before we do that, I want to just demonstrate to you the structure of the project we're going to work on right now. Just give me 1 second here. So you know what we are aiming to do. Okay. And, okay, is it visible what I'm showing? Hello?
Yes.
Yes, sir.
Okay. All right. So the first thing, right? So I've got to show you a picture of what we are trying to achieve. Otherwise, it will be very difficult to understand what's happening. Okay. So this is your oops. This is your autolysis py file, and to this file we are going to send it some data. Okay. This will be your CSV file, and so this will go in here. The next thing, right? So I'm not saying you have to create your project this way, but this is one potential workflow you can use. Okay. What we are going to do today is we're going to make use of a function calling. Okay. So if you remember from week 5, we had discussed function calling, right? So we're going to define some functions that gives us. Can anyone remind me what function calling does? What is the purpose of function calling in one sentence?
It calls the function we have defined previous.
No, in terms of the LLM. What's the purpose of function calling in terms of an LLM?
Is it like sending a context also in the request?
Yeah, but what's the purpose? In one sentence, what is the purpose of a function calling? Why do we do function calling? We can just send prompts, right? Why do we do function calling?
It makes a prompt robust.
Can
Okay,
be
how?
repeated.
Okay, yes, repeated.
To
But
respond our prompts, sir.
To access external tools, like
And
when we were doing weather related or geographical, we are getting some information.
okay,
To respond
you're getting
our
warm now. You're getting warm now. That's good. You're sending something, a function, to get some information back, right? But anyway, GPT is able to send you information back without a function, right? Function call. The reason I'm asking you this question is, if you understand this concept, you will be able to do this project.
Dynamic
respond our prompts,
something
sir.
need what to ask LLM.
Sorry, one at a time. Sorry.
To respond the prompts, sir.
Yeah, that anyway it does. Generate a response, it does. But why function calling?
Based on the prompt, dynamically choosing what to ask LLM.
Okay. Anyone else? So someone said we wanted to get weather data. Can you elaborate on that? Okay, let me ask you a different question. What kind of information are we generally sending an LLM? We're sending a prompt, right?
Yes, sir.
And we're sending, in this case, some bit of maybe some structured data. What do we
Through
want?
the API.
Yeah. So what do we want back from an API? See, for your function, okay, this function, for this function to work, right? Is your function able to work with unstructured data?
No, sir.
No, right? What does an LLM normally give you back?
Unstructured data.
Unstructured data, right? So if it gives you back unstructured data, how will your function, how will your program work? It cannot work, right? That's like speaking in English to your computer and expecting it to do something, right? But it doesn't, right? So that's the big clue. Function calling, the purpose of function calling is to get from the LLM structured data out of unstructured data. That's the purpose of function calling. If you understand this very well, then you will know how to craft the function calls so that you get good structured data back out of your LLM. Because LLMs are good at giving you unstructured information that a human can understand. But now we want to use the LLM's intelligence, but give us back structured data, because our program can only understand structured data. It cannot understand unstructured data. So that's the
So
purpose
can
of
you
function.
more elaborate these things, sir?
Yeah, I will show now, right? So the first kind of function call we are going to do, right, is, so remember I told you we are going to send a CSV, we're going to send this CSV that we have here, we're going to send it to the py file, right? And then we are going to create a function. And this function call, the first purpose, our first function call, so we're going to do multiple function calls today, okay? The first function call, we are going to ask the LLM. So we'll send the LLM the CSV. So we'll send, but we won't send the whole CSV. What we're going to do is we're going to send a small part of it, okay? We'll send a small part of the CSV, say 10 rows or something, okay? We'll send 10 rows and we will send a prompt. So there will be a prompt as well. So prompt will be there as well. And in this prompt, we will ask it to do we wanted to do some analysis on the CSV itself. So what kind of analysis we want to do? We wanted to tell us, can someone give me an example of an analysis you want to do? What's the first thing you do when you look at a CSV? A human being, when a human being looks at a CSV. What's the first thing you do?
Statistical analysis, if it is numerical data.
Very good. That's excellent. So we check if there are numerical columns, right? Numerical columns. Yeah. And we check, what else do we check?
We check if
We
the
do
Remove
info.
missing
rows,
values.
missing values.
Um,
We remove that row, sir.
we can
Yeah.
check like how many is categorical and how many are integer, and after that we can check statistics, and then maybe we can check correlation between numerical and categorical.
Yeah. So we're getting far ahead, right?
Yeah.
Let's go step by step. When we first look at it, you and I, what do we look for? We look for, I like this, we look for numerical columns. We immediately look at numbers. Our eyes are drawn to numbers, right? The second thing, our eyes are usually drawn to whether things are missing. That's true. The third thing our eye is drawn to is whether things may be categorical. So shall we call this string columns? Right?
Yeah, sir.
String columns. Maybe we are interested in whether something is a Boolean.
Maybe date time or that type of that
Yeah,
sort of.
yeah, absolutely. Date time. That's very good. So these are the sort of analysis we want to do, right? Maybe if there are floats or something. Yeah. Now, wouldn't it be nice? Now remember, you cannot see this. This this CSV you cannot see. This is the magic of this, right? You are not
Yes,
allowed to see this.
that is the more difficult things.
Yes. So
So
how are we
whatever
going?
CSV that you decide to use for evaluation.
Yes. So now we need our program, right? Imagine how difficult it is for us to do this programmatically.
Without seeing that CSV file.
Correct. Without seeing the CSV file. Imagine how much code you will have to write to do this analysis. A lot, right?
Yes,
And
sir.
I'll
For
give,
every single possibility, it's a very long code.
yes, very long code. And it's worse than you think. Okay. I'll tell you why it's worse than you think. I'll give you one example here. Now imagine there's an age column. Okay. Numerical, right? So there's some age, 13, 17, and then 1B. So if I asked you what column is this as a human being, what would you say?
Numerical.
You would still
Numerical.
say numerical, right? Even though it says 1B over here,
Oh, yeah.
right? A human being will make the correct analysis. This column is numerical. But if we wrote a function in Python and we ask pandas to look at this, what will it classify this as?
Object
Still,
maybe.
Correct. It will be an object, right? So remember, we are not going to be, this is going to be fully automated. And if we have pandas look at this, this is what's going to happen. So this is clearly wrong, right? So that's why we are going to show you the power of LLM today. Okay. We're going to send it a CSV. We're going to send it this CSV, and we're going to do the first bit of analysis, which is because we can't see the CSV ourselves. We're going to tell, okay, I want you to look at 10 rows, look at the headings of the columns like a human being does, and we will send you a little bit of data, and I want you to send me back two things. Okay, two things we want to send back. Put here two items. Structured data. The first structured data is you want to know the column name, right? And the second thing is why do we want to know the column name? Because we want to know what the column type is, right? If we don't know the column name and if you only get column types back, will that be helpful for us to run the Python code?
No, sir.
No.
Because we don't know the which column is which type.
Exactly. So that's what we will get back from our LLM. Structured data. We wanted to take unstructured data in the sense of we will send it a prompt give it some instructions, send a little bit of the CSV file, and from it we will get back 2 pieces of structured information, because we cannot visually see it as a human being. Your Python code has to see it. Your Python can only read structured data. So the Python, we are telling the LLM, give me back column names and column tags. Okay, so that's the first function call we are going to do. Okay, interesting so far? I mean, if it's not
Yes,
interesting, you can tell me, but so that's what we're going to do first. Okay, and now I'll show you how with very little code. Remember, this will take a long time to write code if you have to write all this code. So I'm going to show you how we will do it very quickly and easily. Okay, stop sharing.
But on that context, giving a subset of data, I mean, for the example that you showed, if it has some kind of string in that,
Yeah.
if you don't send that string, it is as good as we getting the pandas thing output, right?
Yeah, but that's why we're going to deliberately send it unclean data and show you how powerful LLMs are.
Okay.
Right. Okay, so right, we are back here. Okay, now we'll do the first bit of it. So we'll create a function call, right? Remember, when we want to create what do you call for it? Okay, actually, perhaps probably I should show you first the end goal, right? What our JSON data will look like. So JSON. Okay, so here we'll go the model. Model. So this skeleton will always remain the same. I mean, not always, but for the most part, it will remain the same. So we've got model, we've got messages, and messages is always a list, and we're going to have a role and a system. So this is the instructions we give to the to our LLM, and then in content we give content. I know it will complain about this at the moment, but just bear with me. And then another role. This is user and the data we want to send it, right? So content data. Okay. And then
So
these are the
one very layman question here.
yeah.
Both the what to say, these dictionaries are going from our end to the LLM, right, as input. One is like a prompt and another one is the supporting data. Like, why
Yeah.
is there a change in role, system and user? What does that specify?
Why are there change in roles?
Yes,
Yeah.
yes.
So okay. So that's because this is the instructions to the system. We will be giving some instructions, and I'll show you now an example of it. Okay. We'll be giving some instructions. This is what the system has to do, right? But the data is coming from the user.
Okay, system you call an LLM. We are the user and LLM is the system here, is it?
Yeah. So here system is the LLM. So this is the instructions that the LLM has to execute, right?
Okay.
This is the role it is playing, if you think of it that way. And our role over here is we are providing the data for it to execute those instructions. Okay.
Okay. Okay.
So normally we just send model and messengers, but this, because we're doing function calling, which is the advanced feature of LLMs, we need 2 more extra fields. Okay. So one is called functions, and the other one is called function call. Okay. And for now, I'll just leave it at auto. Okay. And
Is there a typo in there?
it's because we haven't declared them yet.
No,
yes,
functions.
undeclared
Oh,
variable.
right. Here you're talking about it. Yeah, that's a typo. Yeah, it will actually not work if you don't give it the right keys, because this specification that you're seeing, you can't name your own names. This is exactly the specification that OpenAI does. So thanks for that. You caught a glitch there, that a mistake I made. So okay. So you understood how this looks, right? So this is our goal. Okay, JSON data. We send the model, we send some content, we send some data. All these keys have to be exactly as shown here. Okay, role, system, content, role, user, content. These are of course variables. We'll deal with that just shortly. And this key also is important. These are the new ones, functions. And we have talked about this in week 5, but I'm just reviewing it here again for you. And function call. Okay, these must be there. Okay, so that much is done. Now what I'll do is I'll put this at the bottom, and we'll go back to creating our actual function call, right? So the first thing we got to do is the prompt we are going to send. Content. Okay, and so first thing we have to say is, and remember, we have to be very clear in our prompts. Okay, otherwise it will not give you the desired output. We'll say analyze the given data set. The first line is the header. And then we can say, and the subsequent lines are sample data. Okay. Then we can say columns may have unclean data in them. Ignore those cells.
Sir, cells or rows, sir?
No, cells. We don't want to ignore rows. Rows can have valuable information, right? That's what human beings do, right? We don't ignore an entire row if there is some unclean data, right?
Okay.
Remember, we are trying to do something intelligent here, right? We're not trying to do something Pythonic or not programmatic. We're trying to make an intelligent program. So ignore those cells.
Do we have to impute as part of this analysis?
Sorry?
Do we have to impute those unknown or blank data?
I'm sorry. Come again, please. You are not clear.
I mean, do we have to do the data impute if there is any kind of a blank cells or
No. We are not going to do any cleanup at this stage.
Okay.
Yeah. See, if you have to do all that beforehand, we have to then know the data set, right? We have to have visual idea of what's happening.
Do
right?
we have to prompt LLM to
Don't worry. We'll get to that.
Okay.
It's ignore while the calculation or any insights from it's involved in that cells.
Yeah. So right now we're saying just ignore those specific cells that have unclean data. Okay. But then what we want is to know what the data type is, right? So we'll say infer the data type by considering majority of values in each column. Now remember, it's very bad at math, so it might not really do well with deciding what's majority or not, but still we will put that in there for clarity purposes, right? It's not completely hopeless, but it's not necessarily the best. And then the next thing we can say is supported. So this is important now. Supported types are, we can say, string, right? And we integer, because we will have certain limitations, right? So we have to tell it what our limitations are, what we can work with. Boolean, yeah, and
Or
yeah.
decimal value.
Good. So, okay, so far I think that looks okay, right? I think, yeah. Okay, so that's fine. Then next part is so data will come to, which is just basically a CSV, part of a CSV we will send. This next bit is very important, how you construct it, okay? So it's called functions actually. So it's a list, functions is a list, and inside the list, each function will be a dictionary, and this construction is very important, okay? So first you have to give it the name of the function. Okay, so we'll call this function get column type. Okay, and then oops. Next we will put a description, and then here the description is very important because it will tell the LLM what this function is specifically supposed to do. So we'll put identify column names and their data types from the data set. Okay. The third thing you need is the parameters for your function. Now, what are parameters? Parameters, this is the magical part now. We are going to give it some unstructured data. We've given it lots of prompts now. We'll send it some little bit of structured data, but we want back structured data. So that's what parameters are. Parameters are the structured bit we want back. It's not parameters we are sending to the LLM. These are parameters
In
we
which
want
format
back.
we want.
Exactly. So that's what it is. So the first thing that is required here is you have to tell that type of parameter it is. So it's object. Then we have to tell what are the properties of this object. And the first property we want is, now if you think about what kind of structured data we want, we said we wanted column names and column types, right?
Types, yes.
But that's an array, right? It's an array. So that's exactly what we'll say. So the properties of this object is, we first have to give it a name, obviously, like you name a variable. So we have to give this array a variable name. So we'll call it column metadata. Okay. Metadata simply means data about data. Okay. So column metadata, that's our variable name. Okay. And now we'll say it's of type array. So it's like declaring a variable called column metadata. Again, we have to give it a description. And this description is called metadata for each column. Okay. Great. Oops. Okay. Now, what does the array contain? So we have declared the variable name of the array. We have told that it's of type array. We have described what this array is. Now we have to tell what the array contains, right? So whenever you declare an array, you have to also declare this keyword called items. Now I didn't make up these keywords, okay? These all come from JSON schema specification. Okay. So remember I told you there was a good resource for this, and I bookmarked it yesterday. So this is very useful. So this will really help you creating your schema. If you follow this, right, it will exactly show you how to create schemas. Okay, so
Can you provide links?
yeah, so we did it, so we learned it from here only. Okay, it tells you exactly how to construct schemas. So it uses some nice examples, and
Sir,
that's
your screen is not visible. You are
oh sorry.
just this now happens.
Oh, okay. Sorry, I apologize. Right, is that working now? Okay. Right. So this is the site I was talking about. This is a very good site to learn how to construct schemas. Okay. If it seems overwhelming right now because we're going through very quickly, you can take your time and understand this. Okay. It's useful to understand. It helps you debug problems because you will face problems debugging. Okay. Now, of course, you can always use the LLM to help you with debugging as well. But if you know what's going on, then it just makes your work faster. So you can see this is a good example of how to construct JSON schemes. I'll put a link in the chat window. Okay. So that's a useful thing. So that's how we constructed the schema. We studied it, and then that's why I'm able to construct the schema. What seems like effortlessly. Okay. Right. So this is the variable name. This what you see column metadata. The variable is of type array. This is the description. This is very important for the LLM so that it knows what it's supposed to do with it. And what are the items of this array? Okay, so arrays always have items, so you need that keyword in there. The first item is also a type of object. Oops. Object. The properties of this object now you have to give. And we have to give it, so we wanted two items in our array, right? First was the column name, right? So we'll declare that variable here. So we want a column name, and column name is of type string. And yeah, that sounds reasonable. The second property in our items is the column type, right? So we can do column type. Okay.
But one thing that we already have the column type, right? Why do we need the LLM to send us the type?
Because we don't know what the type is.
So we can do, right, DF of that, like data frame of that column.
But I already explained, right? If there is an age column and there is unclean data in there.
But suppose we are giving 10 rows as sample rows, right?
Yeah.
And these sample rows does not contain that anomaly that we are getting. Then how would we handle that?
But that's good, right? If it doesn't have the anomaly, that's good. See, the important thing is to correctly identify the column. Now you're asking why does it matter, right? That's what you're asking.
Yeah.
So I'll let me. The easiest way is just give me a second here. How do I share?
So I have one more question. Maybe this is related to his question also. Maybe you can answer to both. Actually, we get this name and type information back, and again, anyway, we are going to send this data to LLM only for analysis, right? Right. So why do we extract only these two now?
Yeah, I'll explain that as well. Why we do that. Okay, so you can see my screen, right?
Yes.
Yes, sir.
Okay, so your question is, you're sending clean. You're saying the row may be clean, okay? And
So
it has
sample rows may be clean.
sample rows may be clean. That's fine. So imagine we didn't do function calling at all. You're saying we can do this without function calling, right?
No, I'm saying we can do this, but not to know the type of that column because we already know what is the type. Or we can do one thing
No.
that.
Wait. So let's go step by step, right?
Okay.
So you're saying we already know the data type of the column. Is that what you're saying?
Yeah, we already know.
Okay. How
Even
would
if
you know? So how would we know? So let's say I have, like I said, this age column, right? This is the information in this age column.
Correct.
You've loaded it in a pandas data frame, okay, called df. Okay, we'll just call it df. Sorry, right? Df. Okay, and then you say describe or something, right? Not describe. Sorry, you say info.
Types.
Right.
Yeah.
This info will give you age, and it will say it's object.
Correct.
But that's wrong, right? It's not object. How do you fix this problem? That's my question to you.
So how LLM will know that it's not object?
This is the beauty of it, right? I'm going to demonstrate that to you, right?
Yeah, you said that the LLM will take the majority of the rows.
Yeah,
like
that's what the
13,
LLM will do. LLM
and
will look
then
at
it will
this,
take that.
right? LLM will look at this.
So-
LLM will look at this word as well that says age. And even if there are some data in there that is of type string, or it's of numeric type also, doesn't matter. It will tell us that this is numeric. Okay. Now this is what we will get back into our Python file. Okay. So
So
we'll
while-
get this.
The LLM will know that because you specifically wrote that into the function, right?
Yes. So now once we get this back, okay, now imagine we got this back. Okay. Now we are able to do something useful with this. We have a column name. We don't know the column name. Remember that. Okay. You have to stop thinking like we can see the columns. We can't see the columns. We just have some column name. Imagine it's column X. Okay. We have a column X. LLM says it's numeric. So now what our Python file can do is it can run a apply function, right? It can run an apply function. And in this apply function, if it encounters any rows that have non-numeric data in it, now it's able to handle it, right?
Oh, okay. In that case, yeah.
Right?
Okay.
But if we don't even know that it's numeric, why would we run this apply function?
Okay.
We can't see the columns, right? We are not, no human being is going to look at this.
Okay.
That's the beauty of it, right? Right. Okay. Right. So let me go back to where we were. So I hope that's made it clear in your mind, right? Why are we doing this? I mean, I hope you see the value in it, in other words. No sound from anyone.
Yeah.
Yes, sir.
Okay.
These projects improve us general thinking.
Oh, yeah, it will. Believe me, it will. Right.
Good.
So column type, right? So column type, you want to know what the column type is. So that's also in terms of a string.
Your screen is not visible, sir.
Oh,
Share
sorry.
your screen, sir.
Sorry.
It's visible, I think. We have to pin again.
Yeah. Okay, description. Okay, so this is the data type of the column. Example, integer, string. Okay. Right. Then properties. Actually, I need to close this here. And items. Okay. So this next bit also is important. So it's called required. This is informing the LLM that it must provide this information. That is, we want the column name and the column type. Okay. And then that's a dictionary. So here, the next thing we want to tell the LLM is, because this was an array, column metadata is an array, we want to tell it, we want minimum, we want something in the array, right? We don't want an empty array come back to us. So at the very least, it should give us one item back. because we don't know how many items will be in the array. Remember, we don't know how many columns are there in this whole thing, right? So min type, okay. What are missing? So that one goes there, that one goes there, that one goes there, that one goes there.
Hello.
Yes, yeah.
So required will be just at the same level of properties.
Oh, yeah, yeah. That's right. Thanks, Jivraj. Yeah. Okay.
You would need a comma after closing the properties, just before required.
Yes. Yeah. Yeah. Okay. Minimum items. But we were constructing it without any issues. I don't know why I can't see the missing bit. Okay, anyway, one more thing we do need also is we require the array itself. So, and that would be at the level of properties.
Is it that you missed a comma on the first parameter, type object? Then
Oh,
object?
yeah. Good catch. Thanks. That's good. So, missed a comma there.
After the description. False,
I mean, we can put
After
commas after all of them anyway. It will not hurt. JSON can have.
the very in the end, you have added a comma at the
Here
end.
we need a comma. Right. Okay, it's correct now, right? This comma I was missing. This one. Okay, and we need at the properties level we need required as well. Required and column metadata. Oops. Okay, column metadata. Yeah. So this is correct now. So we've constructed this. So we have constructed our function.
Sir, can you quickly go through this schema, sir?
Yeah. So first thing is, of course, we have the content, which is our prompt. Functions is a list. So you can see it's a list. Inside functions are many functions, and each function is its own dictionary. Okay. You have to give the name of the function. So in this case, we called it get column type. It's absolutely important to give a description because it tells the LLM what the function does. Then once you give the name, you have to tell the parameters, but the parameters here are what's coming from the LLM to us. So that's why this is so crucial. Okay. So now what we want back from the LLM, we want an object whose property is, so we can have more than one property, but we want only one particular property. That's an array called column metadata. And this column metadata is of type array. We describe what it is. It's a metadata for each column. The array has types inside it. Not types, has items inside it. And in our particular case, there are two items that we want from this array. It is an object with the property column name, with string, and an object with the property name column type, and that's also of type string. And we give the descriptions for those. We require both these things, and array should have at least one item. That's just to get the array to not give us back an empty array. And we require the array itself, right? The column metadata. So all these things we provide and produce this function. This
Okay,
seems a
sir.
little bit complex. This is probably one of the most complex function you will construct. Okay, the later functions that we construct won't be this complex. But the reason I've shown you this first is to show you what's possible, right? If I show you something very simplistic, then you know, it will take hardly a minute, and you won't be able to do any advanced analysis with it, right? So that's why I wanted to show this first. Okay, and this is the most useful thing you can do first anyway, which is analyze the data in a CSV. So I think we've got everything except the data. So let's find some data. Some data. If I go here and pick up some of our favorite data types that you've all been working with for a while. I think in week 4 we had some. Let's get this. Lots of nice columns in there. Download this. Jivraj, can you also send me the Titanic data set as well?
Yes.
Put it on the. I think you put it on the drive, haven't you?
No. Yes, yes. I have shared both house
Okay.
rent and Titanic data in the drive.
Okay, that's fine then. Thanks. Right, so we've got house rent. We put it in there. Right, we got house rent. Okay. df equal to pd dot read, and it's house rent. Yes, you. Oh, and does this pd have to do right? Okay. And then we want to send it from 10 rows as strings. Oops. One change I just remembered. Okay. Yeah, we'll leave this for now. So this prompt could be improved, okay, but we'll leave this for now. And, no, actually, no, we don't want to read it as a. Just remember. Okay, so we encountered a problem, right? So when we opened it with a pandas data frame, it creates some additional issues for us when we are passing the CSV. So instead, what we ended up doing is just opening the file directly and just taking a few rows from it, rather than putting it in a pandas data frame to begin with. Sorry, Titanic house rent CSV equal to
Like, what were the issues with pandas?
what happened is when we wanted to see, we cannot send a data frame itself to the LLM. We have to send it a string, right? So a string representation of our data. So we found it's just easier to open it directly from the CSV, because the CSV is clean text, right? So, and we only want to send a small amount of data to it anyway. And
But we can send key value pair to the LLM, right?
you can do different methods. We can try different things,
Okay.
but we've tried this and it works. So we'll just do this for today. But again, there's no restriction, right? You can, sky is the limit. Whatever works for you, you can you can use. We found this worked well for us. That's the only thing. But yeah, whatever you send it, even if you send key value pair, it still has to be a string. Data that goes to it has to be some sort of string. Okay, so even your key value pair, you'll have to like convert it into a string, like a JSON dumps or something like that. Okay, let's run this cell and see. Yeah, so that works. And if we examine, yeah, you can see here it has loaded our data in the form of a string, right? That's fine. And then, if I remember correctly, we have to JSONify. I think we have to import JSON for that. Import JSON. Import JSON loads. JSON dumps. Functions. Okay, so what I've done here is, okay, I've read this as a string. I want to JSONify it and then send it back as a what do you call for it? Something that the LLM can process. So that's why we have done it this way. And then I think all that's left to do is to send.
But you are converting the function to the JSON, not the data, right?
Ah, yeah, sorry, yeah. You have converting this into JSON. Yeah. Content. Yes. We didn't run this bit. Oh. Right. So the only thing left now is to.
Sir, can you
Sorry?
explain the function part in that JSON data?
So what I've done is we have extracted a string, okay, and the way we have extracted the string is we have looked at the 10 rows, and yeah, we've looked at the 10 rows, and then we have joined those 10 rows into
Make
a single, yeah, into a single
line.
string, yeah, and then the JSON function creates something that can pass this information so that it's readable for the LLM to process.
Sir, that things I did not get, sir. Do you call JSON.dumps function?
Yeah.
Sir, what is the goal of that doing this, sir?
Because what it does is it converts this bit in, it puts, if you look on here, this string, right, it doesn't have these what do you call for those quotes and things like that. It doesn't have, right, it's not formatted properly, these things. So JSON dumps gets it into that form, and then this produces a dictionary out of it.
Okay.
Can you please JSON
produces a dictionary out
Yep.
of the output?
So if I do this, right, if I do JSON, yeah, that's what I'll just show you. JSON dumps and do functions. You see this? Can you see this?
Yes, sir.
Yeah, what it did is all these things that were here.
It's not that data, right? You have written functions there inside that dumps function.
Oh, right. Yeah. Sorry. My bad. I've completely lost track of what I was doing. Okay. Yeah. So data is this string that we're sending. Remember, I told you can't send JSON to. Sorry, I messed up my words. What we send to the LLM, the data, we cannot send it anything other than some very specific types, right? We can only send it a string. So that's what data is over here. This is the functions that we have created here. We have converted it into a function that it's able to read. So this has to be some sort of JSON that, just like the rest of this. See, this is all JSON, right? All this. So this has to be in a proper JSON format for it to be able to process this. So that's
Okay.
why we do this.
The
But
schema.
but the data has to be a string.
Okay, sir. You JSON don't dumps that function you created, right?
Yeah.
That's and then you loads that schema.
Yeah.
JSON dot loads.
Yeah. So if
Uh,
you look at the output of this now,
hmm.
so this first function stringifies it. Oops. This first function JSON.dump stringifies the functions.
Mhm.
This then converts it into a proper JSON that LLM will accept. The reason we done this is we ran into problems when we were sending the request, where we kept getting errors because it had issues with the JSON. Okay, so we found that when we stringify it and then load it, it works correctly.
So another way is you can read it using pandas and then you can use two JSON and later you can convert it to a string.
Yeah.
We had done this also after some time, right?
So try to run that thing, sir. JSON
Yeah.
dot.
You mean this thing you're talking about?
Yes, sir. Yes. That. Hmm. Okay.
Okay.
Yes.
Right. Let's send the request, shall we?
So, but this is nowhere different except for the open brace and the close brace at the end than what we have created, right? The
Didn't
original functions variable, we
Hmm.
also defined it in a proper JSON format, like proper keys and values with codes and all.
Yeah. The difference was when we did it over there, I think it was with the double quotes or something. And JSON doesn't like double quotes. It always, I think it's required for JSON for them to be single quotes, I think, if I remember correctly. Does anyone remember? I think that's what the specification requires.
What, sir?
Yes, it doesn't accept double quotes, I guess.
Yeah. And there is one more thing which I just remembered now. So if you've got Boolean values, right? In Python, a Boolean value is capital T R U E, right? But that's not valid
Yes.
JSON. So that's another reason it's always better to JSONify it and send it.
Okay, sir. Okay.
So we ran into several problems. We found that once we cleaned it up this way, then anything you send it will be correct. I mean, as long as it's structured correctly, of course. So that's the key issues we faced. Okay, so we'll send the request.
Yes, sir.
Okay.
Ready to launch the rocket.
Yeah. I mean, this is not even launch. This is more like countdown.
Yes.
We have yet to show you something truly mind blowing. Once we show you that, you'll be like, oh wow, that is really cool. But this is probably the most complex function you will construct, okay, because of the array. But the reason I didn't want to show you a simple one is because we have done in week 5 a simple one. I wanted to show you something a little more robust.
Robust.
Okay, so something is wrong in this. Oh, did I say Boolean?
That minimum item, that min item that you specified is one. That's not string, I think. Yeah, this one.
1 second. No, that's fine. Sorry. Got my mistake. Name column by description. Let me invalid function parameters. Yeah, we ran into this problem before. So name description. Yes. Okay. All right. I apologize for this. I made a mistake here. I was referring to the. Okay. Just give me 1 second, please. Put this here. Function. Okay. Parameters goes here. I do apologize for this. I made a slight blunder in this. So even we get it wrong sometimes. Type goes here.
Countdown fails, sir.
Sorry, what? Yeah. These things will happen. So type object, type parameters, properties, column metadata, type array. Right, so I've got name, I've got function, I've got name here, description, parameters, type. I need the properties here. These. Okay. And then column metadata, type array, description. Actually, I'll call this. No, that's fine. Okay. Items, type object properties, column name, type description. This is all correct. This is all correct. Required was properties. Min items should come here under column metadata. Yes. The one annoying thing about A and need it after items. So that is after items. Yes.
Min item should come one level above, right?
Yeah, I think. Yeah, I think this required. No, min items. Yeah, comes one above. Yeah. So min comes under items. Yeah. So over here. Okay, and then required also will move one above. It will get easier from here on. This is the hardest function call you'll see. So if you get this right, everything else will be easier. Okay. So now just have to check for commas. There's comma there. The brace here. The brace there. There should have been an easy way to fold these, right? Then it could have been easier to see. This goes in here, I think. Yeah. Okay. This goes in. This goes in. This goes in. Column type. Yes. So this comes here. That goes here. This goes here. This goes here. That goes there. There. Aha. Okay. So that's for properties. This for parameters. This for function, and then we need one more here. Hey. Okay. Right. Okay. This is the correct structure.
There is
I'm
one
90. I'm 90% sure. Sorry?
Required, I think.
Sorry, what was that?
The last required, after that there is one comma extra.
That won't matter anyway. Okay. Okay, so name, function, then name, description, parameters, type, properties, column data, type, description, items, type, properties, column name, type, description, column type, description. Yeah, I think this will work. Okay. Oh, nice. Okay.
Sir, what are you saying? Was saying that, sir, 90 per.
Yeah. I mean, we'll know once we run it, right? Right. So let's rerun the request. Something's happening. Oh, still not right. What's wrong? Okay, I got an idea. Let's run from top. So this all is fine. This all is fine. Fine. Oh yeah, I forgot to. Man, I'm so stupid. I forgot to rerun this cell. Okay, that's what.
Run all.
Yeah. No. I just wanted to check if there were any issues along the way. So that's why I didn't say run all 20, 38, 39, 40. Now I think it will work. Oh, okay. Right. So we got to change this. So remember I was telling you, yeah, we have to give it a function called name. So we call it get. Oops. I think it was column type, right? Wasn't it get column type? Yeah, get column type. Okay. I think that fixes that.
Run the cell, sir.
Yeah. I think that we've got to run the cell. Okay. Right now. Guys, did this not?
Run the last cell.
I did this, no?
The last r.json you do not run. Sir.
Oh, I didn't run this, is it?
Yes, sir.
Oh, yeah.
Yes.
Okay. There we go. Right. Except there's a problem.
Something
Can
with
it?
sir.
Can anyone spot the problem?
What, sir?
So this is good. Okay, this is
It
working
didn't
now.
give, it didn't give the answers as expected, right? We asked it for accepted values as string, boolean, something. But
Yeah.
it's giving monthly request is here 4 and something.
Yeah. So now before I continue, what we'll do is we will.
So we get the answer or not, sir?
No. So,
No.
but before we get the answer, we'll do one thing. So first thing is we got to know where the answer is, right? So if we do the key we are looking for is choices.
Choices.
Yeah. So if we do that, and then we are looking for in choices, we're looking for function call.
And messages.
Oh, right. Sorry. Oops. That would be choices. Message. Sorry. It's in message, right? Yeah. Message. Oops.
It's an array.
Oh, was it? I didn't notice. Let's see. Oh, yes, it is. Yeah. So the
Of
first
0.
item. So yeah. So zero.
Zero.
Yeah. And then inside the array, it's message. Let's try that. Yeah. And inside the message, it is function call. Okay. And now we have a problem, right? Sorry, someone was speaking?
No, sir.
Okay. So we have to identify what the problem is. So it didn't give us the response we were expecting, right? We wanted some array to come out. It didn't come.
Can we give function call equal to just auto?
No, I'll show you a better way. So we can give it auto, okay? But the thing is, it's better if we actually specify the function. So what I'll do is, I'm going to make some changes now, okay? Maybe perhaps our prompt is not that good, okay?
Sir, copy that prompt and give to ChatGTP to give the better prompt.
But it doesn't know our intent, right?
Okay.
So the reason I'm showing you this is to show you how different prompts will make a major difference.
Such a hard case to convince the LLM.
Sorry to interrupt, Carlton,
Yeah.
but we are not passing a CSV file to
Yes.
the LLM, right? We are just passing a string.
Single string, there is no header columns.
Yeah, that's fine.
So why you
But
giving
that's how it receives a CSV. So that's why, see here, what in our first prompt, we didn't really give it a clear prompt about what we are sending.
Okay.
Okay, so that's why it failed. So now we'll give it something more precise. Okay.
Okay, sir.
Now see if you notice the difference. All right. So we ran into problems when we were working on the LLM. So part of using the LLM is trying to precisely explain what the issue is. So here it was this first type of prompt that we gave is a bit more sort of generic, right? There's some specificity in there, and then we can try something different, right? Where we specifically say, okay, you're tasked with identifying columns from a CSV file. So now it knows, okay, it's a CSV file. So there are going to be comma separated values. First row represents header, following row. So the reason it would know the rows is it will look at the slash ends, right? Okay. Then analyze the given data and return a JSON object with each entry as the column name and its inferred data type. And then the response should use, and now we have told the function for it that we wanted to use, right? So that's one change we have made. And then what else? Okay, this all is fine. Array of each column, blah, blah, blah. Okay, it's fine.
Run that column, sir.
Yeah. And then, yeah, okay. So now we will run this one. These are all remain the same. Let's see what happens. .8 seconds. Okay, I'm not sure what happened there. Let's look at the actual JSON. Okay, it still didn't work. So something is still not right. Okay.
So sorry to interrupt, it is showing prompt tokens and completion tokens, right? So what is the completion token that we are spending?
So the completion token is for the fact that we have sent it some things and it's responded to us.
Okay, and prompt tokens vary depending on the size of the prompt.
Yeah. So prompt tokens is what we have sent, right? 535. It responded to us, so it gave one token. The nice thing is because it didn't send us much, it just took one token to give us practically nothing. Okay, so for some reason it is not working. The question is why.
It might be that it's not the we are but the data we are sending, it's not accepting that string that we are sending.
The string you're talking about, right?
Yeah.
Yes, sir.
I'm trying to find. Jivraj, are you on the call?
Yes.
Okay. Can you see what you're missing?
Can you show that function where we are making call?
1 second. Functions. Sorry, you're talking about this. Are you talking about this, or you're talking about
the other one, JSON data? Okay, it's model functions.
Is this model is defined previously?
Let me run this from the top anyway. Restart.
So can we just stop asking it in this functions format and instead only give model and messages? So we can see the unstructured response at least, right? So we can debug whether it is HTTP data or the function.
Yeah, that you can always do. That's no problem. You just have to modify this. That will work just like a normal prompt.
Yeah, that way we can identify whether our prompt was weak or our function call was wrongly constructed.
It worked for us yesterday, so what am I missing?
What is this model in the second line that?
This is from here, up
Oh,
here.
we defined already. Okay. Yeah.
Oh, okay. I know what happened. Let me clear the outputs. Okay, that's better. That's fine. We want this one, right? And the other thing we want to do is we'll actually run this content instead of the other one. And then run this. Now it's creating an essay for us. So now it's giving us what we call unstructured data, right? But this is not useful to us. This is okay for chats and all, like creating a bot or something, but this is not useful for us. This. It comes under message content, I think. And then if I put that into a variable, word wrap. What? So this is what it gives us at the moment, which also I think includes markdown in here by the looks of it. So it's doing what we're asking it to, okay? But the problem is this is now unstructured data. This is not going to help us. We need to get it to put the output back into structured data. And it worked for us yesterday, and I'm not sure what I've done differently today.
Now let's try with that function now.
Yeah. No, I'm just trying to compare it. Compare it with what we did yesterday. So this is the function. So I've got a name, I've got a function, and this one. Okay. Okay. Okay, just give me 2 seconds, okay? Just give me 2 seconds. I mean, the one thing we can do, I've shown you how you can create a function call. We can do a simpler function call and keep moving forward. That's something we can do. So I can show you at least
I
something.
think required is at wrong place for column metadata.
Sorry?
In the functions, I think required is at wrong place in column data, metadata. It should be at the same level of properties, and it is within properties. This required should come below, right?
Oops.
The second one.
Oops, sorry. Here, right? So we're talking, this required you're talking about?
No, the other one.
So this is properties.
No. See, the properties, yes, this is properties. So it should come outside the properties.
Okay. All right. Is that the only thing that's different, or is there anything else that's different?
I think that is the only thing. That's
okay. You know, we created a notebook yesterday, no, Jivraj? Can you run that notebook and see what output you get out of it? Thanks. We didn't change the we didn't change this, right? No, I'm not getting the output. Something has gone wrong with this. Okay, so one learning from this, I know it seems like we didn't learn anything, but actually we have learned some important things, is that constructing functions is a little bit of a skill, okay? And we have constructed one successfully before. Actually, we've constructed several, but this is the most complex one that we have ever done for me personally and for Jivraj. So we were not able to get this working correctly at the moment, but we will.
Hello?
Yeah, go ahead, Jivraj. You were going to say something?
So I ran the notebook and I'm getting the column name and the data type of it.
Oh, you're getting the output. Okay, why don't you demonstrate it on your system then? Not sure. We make there's some mistake I've made in here for sure. So you can show it on your notebook. I'll stop sharing. Just start from the top, okay? So we can see exactly how it goes. So yeah, so there's the opening, we read the file, okay, that's fine. Get the tokens, headers, URL, model, that's fine. Okay, yeah. So this is the function you're running, is it? Yeah.
Yes.
Okay, yeah. Yeah. Okay, keep going. So far it's all mostly the same. Functions, function call. I think with functions, function call I've done that, haven't I? Functions, function call.
And in the function, you JSON.flow.
Jivraj, that functions of yours, right? What did you do with that?
I passed these functions.
Okay, you passed it directly. Okay. All right. No, that's fine. Don't change it. We'll see how it goes.
I think that
But
doesn't make difference. I think it is same thing, right?
yeah, but okay, yeah, carry on.
But after that justifying it, it's giving inside a list, right? So that's why it's giving wrong.
And
But
if
this,
the post,
but this also is a list, right? This also is a list.
Yeah,
Oh,
it is also list.
okay.
there is a post method, sir.
Yeah. Yeah, I'm doing a post as well, right?
Can you show that functions what it is? I think that there is a difference. What we have parameters.
Okay. So yeah.
Column.
So you can. So when you run this, you're getting the output, is it?
Yeah. So here, I'm just getting the
Sure,
arguments.
Yeah. That's fine. Can we look at the
This is
output
what.
though? Brilliant. Okay. So this is the output we are expecting, right? The column name and the column type, and this is precisely the output that we are expecting. We'll have to analyze after this session what difference there is. Okay. So now
Maybe it's wrong with this itself.
yeah, possibly. Yeah. So maybe there's something minor is the issue. We'll have to figure out that later. But can you show the output at the bottom for us? Is that the house rent one? Is it?
Yes, this is house rent.
Okay.
And the functions what we have written now, I think there is something internally we have written one more tag called function like that. I think maybe there is something wrong in that function. So
Yeah, possibly. We'll have a look at it and diagnose it next session. So I can tell you the error. So you will learn from the error. Okay. Jivraj, can you make it a little bit bigger so we can just see it? Okay, thanks. So if you look on here, now what we have done is we have sent it some data. Can you show the data that you sent, Jivraj? Just put a code cell and say, yeah, that's fine. So as you can see, the data over here is all in a string, but it knows that it is what it's supposed to infer the information on. And when you look at the metadata at the bottom, what we got out of the LLM, it tells us exactly the column name and the date.
I'm sorry, Martin, can you ask Jivraj to mute?
Jivraj, can you mute? It's very noisy where you are. Okay. So I know it took a bit of time to get to this, okay, but it's mostly some minor formatting error, I think, okay, with our function call itself. But now this is the amazing bit, okay. If Jivraj now, so Jivraj has run this on a CSV that we have not seen at all. We don't know what's in it, okay. But now it has given us vital information about two things, which a pandas data frame can work on. First of all, it gave us the column names, okay, which is great. And the more important thing is it told us exactly what's in each column. Now, Jivraj, can you make modification in that CSV and change one of the values you've given 10 rows, right? So change one of the numeric values in, say, size or not size. Yeah, okay, yeah, size or rent or one of those things. Can you make change in one of those numeric values and then resend the information? Okay. So remember, theoretically we don't know what data set it is. Okay, because that's what's going to happen when your data set reaches our server. We will just run your Python file, right? And it's going to have to decide what everything is. So which column did we change, Jivraj?
4, column 4, row 4, row
Size.
4.
So we changed size, right? Yeah, so that's great. So let's have a look and see if it decides what size is. Okay, so it says string, right? So there is some error here, right? This is not useful. So the one change we made to the prompt yesterday, that fix that problem is, we said, examine the column name carefully and make its inference based on the column name, isn't it? That's one thing we made, I think, Shivraj, if I'm not mistaken. That's one of the changes we made to the prompt. Because you're running zero analysis, right? So the notebook with zero analysis. We had made a change to the prompt to fix this problem. Look at house prompts. Yeah. No, that's that was for our second function. Yes, yes. Is this the one?
Yes, it is there. Consider carefully name of the column while making a decision.
Yes, yes, yes. This is. So Jivraj, can you make a small change to the? Can you make a small change to the prompt so that it doesn't change the data type? So today we basically started with the most hardest function call you could make, and then we will show you next some of the more interesting aspects of it.
I corrected that functions. I'm getting that output.
You're getting it, is it?
Yeah. I think the original functions what we have written was correct. So later we modified some syntax, right? So
Yeah.
to be the issue.
Okay. Thanks, Pradeep. Okay. Can you run the modification, Jivraj? Great. So now it has, although it used to be an integer, float is fine. The reason is when pandas data frame is working with floats, even if there are strings in there, we can deal with it using the apply function because it makes it like float 64 or something like that. And then we can clean out those values that are that have an issue. But the beautiful fact is it is still a numeric column, even though there is a string in there. Can you change one more column and try something else? So you see, it is still considers size as float, even though there were two strings in there. And this is something that we now I can show you a data flow that comes out of this. Okay. So thanks, Jivraj. You can stop sharing now. So have you guys understood what's happened so far? Do you have any questions? I know it was a bit of a lengthy debug to try and get it to work. But have you got any questions so far?
No questions.
Okay. We will not be doing such complex function call for the next segments. Okay. But that's the most hardest one. So we showed you the most difficult bit. So it gets easier from now on. Okay. So we get the column types. That's great. Now our ultimate goal was to create some charts, right? So the LLM now knows, just like we would, what the column names and what the column types are. So potential workflows. Once you get the column names, column types, you can now run, based on the data types, you can run some cleanups on it. So you can run some cleanups. So if it's numerics, you can get rid of string values or nan them or whatever you want to do with them. So you can make them nans, or if it's if you feel it might be appropriate, then you can ignore these rows possibly from your data set. Another thing you could do is interpolate.
These works we do in our code itself, right?
Yeah. These we will do in the code, but the thing is, before you didn't know you could do this, right? Before, if you had just a pandas data frame without the LLM, if you just had a data frame, it would say object. Your code would not know what to do with it, right? So if you tried, for example, to convert this, and it was actually a locality, okay, locality. If it was locality, and you try and run this to make numerics, right? What will happen? Your entire data set will disappear, right? Yes.
Yes.
So that's the value. That's the value of having an interpretive response, right? It gave you a JSON. See, that's what Jivraj showed you, right? When it gave us unstructured data, which I showed you, right? We looked at the prompt, it gave us a whole bunch of text. Your Python file cannot deal with it. But with the structured data that it gave back from this function call, it gave you this nice structured JSON back with the column name and the column type. With that, you are able to do something powerful, because now you are able to make a decision. Your Python file is able to make it. If it's a numeric column, we can do some cleanup. So that's one type of thing you can do. So what about the other columns? So now you can make a decision on even string columns, right? So can anyone tell me what kind of activities you could do on a string column? What kind of analysis you could do on a string? Okay, even before we go to string, let's exhaust this numeric bit a bit, so that we know what we do. Okay, so you can make nans, ignore rows, interpolate results. These all things you can do. What else can you do? What other decisions you can do on numeric columns?
You can see average.
Pardon? Could you repeat that again?
Average values.
Yeah. So you can do summary statistics on it, right? Is that fair? Shall I call it summary statistics?
Yes.
All kinds of summary statistics you can do on it. Whereas before, if it was a column like locality, and you decided to run cleanup on it, a numeric cleanup on it, you would have no data to work with. But now, because you know it is a numeric column, you can run summary statistics on it. Okay, so that's something you can do. What else can you do on this?
Eliminate outliers.
Yeah, so outlier detection. Oops. Outlier detection. Okay, right. One more thing. I'm still looking for one more type of analysis you can do on it.
Heat map?
Correlation.
Yeah. Correlation, heat maps, all these sorts of things, right?
Trend line.
Yeah. So these are all, so I'll just put ... for the rest of them, okay? So these are all interesting things, but they're complex, right? So I'll suggest something simple for now. Okay, I'll keep this down here a bit. Can we make them binnable?
Binnable means?
So make numeric data into bins.
So the scale will be different, might be different for.
Yes, very interesting. So how do we know if a column is binnable? That's a good question, right? But it could give us good insight, right?
It can be based on number of unique values it takes. There's a number of uniques.
Yes,
We can
very good.
group them.
So two things we have to look for. How many uniques are there? And the other thing we have to look at is maybe the range of it or something, right? What from where to where it goes. Then we have to look at the total count of the column, right? Others we cannot know. So say for example, there are 10 uniques and there are 1,000 count. This is a good one to do a binning on, right?
Sir, so for all of this type of analysis, we have to run the Python program, some definition of code that's do that things, right?
Yeah. So now I'm going to show you something pretty cool.
So LLM gives me codes. How can we run on that thing?
Yeah. So now remember what we got back, right? We just got back that it's numeric or whatever string or whatever. We got that information back, right? So the next part of the workflow, okay, is we got a column that we say it's numeric, or it could be categorical or whatever it is, and we want to now find out from the LLM, hey, we'll run some now because it's numeric. We'll run some stats, right? These are easy stats to run. Unique is just one line of code. Total counts is just one line of code. We can use the describe function of the DF, right? Pandas, and it will give us some kinds of statistics, right? Some summary statistics it will give. Just basically 3 lines of code, right? What if we send this to the LLM and now ask the LLM, hey, is this data binnable, right? Is this data binnable? And that will be something useful to find out. Now you may say, hang on a minute. If it's numerical, it's probably always binnable. Can anyone give me an example of a numeric data that is not binnable?
So should we do it for every column, every numerical column?
Yeah, do it on every, because you don't know, right, what's in it. Your Python program doesn't know. Your Python program is brainless. Numeric data that is not binnable. Can someone give me an example?
Yeah, columns like bank balance.
Maybe. I'll
phone
write it here.
number,
I'll write it
employee
here,
ID.
but I don't agree. I'll write it here, but I don't agree.
Sir, employee ID or phone number.
Excellent. That is a
PIN
great
code.
example. Employee ID.
Aadhaar numbers.
Aadhaar numbers. Excellent. Aadhaar numbers.
That's some serializable numbers. Don't be
Correct.
binnable.
Social security numbers, right? SSNs. PAN card numbers. These are all not binnable. These are no meaning if they are binned.
I think
In fact,
banking is not binnable, sir.
Yeah. So all these things are not binnable, right? So wouldn't it be beautiful if the LLM, see now your Python program has no way, zero chance of being able to identify that, but an LLM can. So that's what our next job is. So our first workflow was tell us the data types, and it intelligently guessed the data types. The next part of the workflow is find out the binnable bits, right? We don't want to bin Aadhaar cards or social card numbers or any things that are useless, right? So we don't want to bin those. So that's the next part of our workflow. But you might say, hey, hang on a minute. Before we even get there, what if there are some errors, right? What if there are some errors when we are trying to do these function calls on this, right? We are assuming that these are numeric, these are string or whatever it is. What if we get some errors? So there's a simple solution to that. If you get errors, when you're processing each column, simply catch the error and don't use it for your analysis. So then whatever you're left with are the things that you will send to the LLM. You'll send columns with their data types and ask the LLM, is this categorical? Is this binnable? That's what we will do next. Okay. So that's the next part of it. And then once we do that, okay, because we won't have time to demonstrate it all in one go, I'll just tell you the workflow that we are working towards. Once we get whether it's binnable or grouped or things like that, the next aspect of it is, let's make some charts out of it, right? So LLM will give us a response. Saying binnable, or it's a categorical variable, right? And we want to make some charts. But now, how do we know what charts to make? We don't know what charts to make, right? And more importantly, we don't want to write any code for the charts. So what we'll do is we send back to the LLM. We'll say, choose a chart. Okay. Write the code. And then the LLM will get back to us. It will send us code. And it will tell us the chart type. And this all sounds like magic, but actually it works. We will execute the code.
What was the line before choose a chart and write the code? Just before that.
So
Binomial categorical, what is that?
yeah, it told us if this column is worth doing a certain type of analysis on it, right?
Okay, okay.
So in this case, I just chosen a binnable categorical one, right? It could be anything, like some of the examples you guys gave, which is regression analysis, correlation, heat maps, all these things. Okay. But that's for you to decide how clever you want your project to be, right? So I'm giving you a simple example so that you understand the workflow. So LLM said, okay, this is binnable, this is categorical. So then we say, right, choose a chart, but I don't want to write the code for the chart. So choose a chart and write the code as well. Okay. The LLM will then give us code and tell us the chart type. And then we will execute the code. Remember, this is all being done automatically. Okay. There's no human involved yet so far. Okay. We will execute the code, but our code will give us errors, right? Does LLM write perfect code? No.
No, sir.
Right. So code will give us errors. What we do with these errors? We will
send it back to LLM for fixing.
We will catch these errors. Okay. And then we will add the code to the error. And then we will send this back to the LLM. Oops. Okay. It will send it back to us again. And we do this loop until two things happen.
No error.
No error.
Or get correct.
So we can put a limit, say 3 tries or 5 tries. Right?
Yes, sir.
Then once that happens, and this sounds like magic, and it really feels like magic sometimes. And we have working code that shows this, by the way, which is what I wanted to try and get to, but we spent a lot of time trying to debug that first complex one. Once we get this back, you will have a chart. Remember, this chart, the LLM itself will create, okay? The PNG will come out of your program. It will create the chart. And it will eventually, what you wanted to do is also give you a README. And then this bit, you get some overall analysis of your data set from it. So this is the workflow.
Where did we decide on what 3 better charts could be, or what columns could be better to include in our analysis?
Yeah, so choosing the columns, you'll have to, so this is where this is why the first bit was so important. I know it sounded like a silly thing to do, but once you know what your column names and column types are, then you're able to ask the LLM to decide which columns to use for, say, a correlation, which columns would be appropriate. You ask the LLM itself to choose. So that would be one type of project, right? Where you ask the LLM to choose the columns. Then you send it the required details of the columns. And I know we haven't shown you the workflow yet, but that's part of what we will probably cover, say.
Sir, one doubt.
Yeah.
If
Sunday evening we can cover it.
okay, if LLM gives any code,
Yeah.
how we run that code in that our autopilot
Yes. Yeah.
py that things
Yes.
to us.
So what will happen is LLM, you know that I showed you that it sends you so in function calling it will send you structured data, right? But when you're going to prompt it for code, we don't want it to give us so we will send a function call, but in that function call we have to make it very specific. We have to say give let me see if I can find the exact prompt we use. It's so the prompt we used said generate only Python code, do not add comments to code, create the pie chart for the column data, use column data statistics to provide, use the column data statistics provided to get the column name and generate the code for the appropriate chart. Export chart as PNG. So we said that, and then we created a function call. These function calls are much simpler than the one we showed you, okay? Because these are not that difficult function calls. Only the array creation one is the hardest one. That's why we showed you first. But the rest of the function calls, these other things that I've talked about, these are actually very simple function calls to make. And we'll show you the construction of those function calls next time.
Okay, sir.
Yeah, because it's nearly 11, right? The session has gone 3 hours.
Yes, sir.
So, but I hope you are getting to see that there is some beauty in this. And our code runs completely without human intervention.
Only
That's
we have
the,
to command line run that file and give the CSV file,
yeah.
and all about us to do LLM. What about the CSV file contains?
Yeah. Yeah, that's it. I mean, that's the workflow behind it. Any questions so far?
No, sir.
Was it?
Now we made some assumptions, right? Here, for example, we discussed about numeric or
Yeah.
categorical data.
Yeah.
Okay. For example, if we take the example data sets that are given,
Yeah.
one such data set is media.csv, right?
Yes.
So that media.csv has some categorical data which is comma separated integers and all.
Okay.
So that if I look at that data, probably what kind of inference we can bring in, it's more like we can split that records and then use for some kind of networking kind of things, right? That is what I can infer from that data.
Yeah, but remember, be very careful when thinking about it, right? Because you have to approach it from the point of view you cannot see the data.
Correct. That's where I'm coming up now. So
Yeah.
now we don't know what kind of data would be coming in. So
Yeah.
if we make these kind of generic numerical and categorical datas,
Yeah.
and
These were just examples I showed you, just so that it's easy to understand. That's why I done this, because obviously I'm trying to explain it to the broadest audience possible, right? There's going to be varying levels of people who are going to be trying this out, right? So that's why I gave a simple example, but you can construct complex things. It's not that you can't, right?
okay.
But you have to think carefully about it, is all I'm saying. Make sure that you have a good loop, right? A loop, and that's all this comes down to. Have a good working loop. The loop should be able to take anything and it should generate something useful to you. You should be able to act on the response, because that's the only thing your Python program can do. Your Python program can only respond to structured data, or in the last step, which I showed you here, and this is the most best part. Okay, I know we didn't get to it today, but the fact that you send it instructions, it sends you code, you send the code back with its error, and it auto corrects itself, and ultimately gets you a result, an actual working result that outputs even a PNG, right? And you didn't write any code for it. That is just mind blowing. A program that writes itself.
Our program in itself is a small LLM.
Yeah. I mean, because we are leveraging the power of the LLM, right?
Yes.
So one more thing is, I see that CSVs generally can be seen as two categories, in which one has just a dump of data, and in other we can say that few columns impact the target variable.
Okay.
Did you get it? Like if I collect the marks of students of a class in a CSV, that
Yeah.
doesn't have any result column out of which I just have to interpret the trends. But
Yeah.
these data like house price or something like price of something,
Yeah.
there is one target column and all the other features impact the target column. Whereas in students mark list, it is not like that. So these two CSVs, I think, need different kind of analysis.
Yeah.
So how do we handle that since we don't know what is there in the CSV? How do
Yeah.
we presume that it has
So
the result variable?
yeah. So one thing that comes to my mind, if I were constructing this for real, is I would, once I get back from the LLM, see, remember, you don't want to do too much in one go from the LLM. It will not be able to handle it, right? That's why we have to make it in this loop fashion. Okay. So once we got back the row names and the data types, one thing that I would have done is send all those row names and data types back to the LLM, right, as a fresh prompt, and then say, suggest some analysis, or suggest some statistical analysis that are typically done on these types of data, and LLM will give you some sort of response. But remember, your function calling, right, has to be something that your Python code can act on. So you will have to, for example, if you decide, okay, my project program will try to do correlation analysis or heat map analysis or any of these sort of things, right? You will decide on a subset of things that you're ready to handle, okay? So you'll have like a menu of things that you're willing to handle, okay? So in the function call, you tell the LLM, these are the this is the menu of things that you're allowed to suggest, right? And from this menu of items, suggest me something that will be able to, give me something that's good to do on this data set. So it will then shoot you back. It will say, okay, correlation. So then you do a switch case and you find, okay, it said correlation. Then you will have a specific prompt if it says correlation. So the loop then becomes, if it says correlation, I will send this particular type of data to it. And that's another thing you can engineer in your function call. Not only tell it to give you the suggestion of the analysis, tell it which column, ask it which columns to do it on. So it will send you two types of structured data. It will send you, this is why I showed you the array function calling, right? Because you want 2 bits of information that come out of it. You want the function type, and you also want the columns it wants to act on, right? So then you get that back from the LLM. Now you got the function, the column names and the analysis type. Then you shoot it back to the LLM and say, okay, write me code that will produce the required analysis on this. So you can make it as complex as you want. The loops can be as large as you want, or as numerous as you want. But you'll have to think carefully about each function call construction, and then uh, create the workflow that will enable it to happen. But my advice is start with some simple ones first, so you get the hang of it. And once you feel confident, okay, hey, this is actually generating something that's quite useful, then you can add some complexity to it. So one of the items in your menu of analysis can be something a little more complex, but you can leave that for later when you get a bit more confident with how this loop works. And we have created a complete loop ourselves. So that's what I wanted to demonstrate. But like I said, we ran out of time a little bit today. I hope I was not going too slow. I mean, I was trying to be as clear as I could. I mean, was that, is that helpful? Does that give you clarity about it?
Yes, it gave somewhat clarity, but we have to try different things now.
Yeah,
But
yeah,
actual workflow we could understand.
yeah. Because before it was a very vague thing, right, in your mind.
Correct. Yeah, yeah.
Yeah,
It was not at all clear.
yeah. This next part, I really wish I could have shown you, because this next part takes the data type, the next part of our analysis, and it then it gives you an idea of that flow. You know, we got the data types and the thing. We did a summary statistics like you suggested in the, I think you suggested earlier, right? Do some summary statistics on it. So that's what we did. We took one of the columns and we did summary statistics on it. Sent the summary statistics to the LLM, and then in the prompt we just told it, okay, tell us, you know, if it is numerical and binnable, you know, and gave it some examples. So we also did what's called one-shot training. You know, if you remember from week 5, we did one-shot training, right? So same thing we did. We gave it an example of what are binnable and non-binnable, numerical but not binnable, so it understands the context, right? And then we told, okay, go ahead and tell us, is it binnable, not binnable? And the way we ask it to tell us, again, we wanted a structured data. So we said, okay, respond to us as a Boolean. Give us a, so we gave it a variable called flag and said, if it's binnable, send us back just the number 1. If it's not binnable, send us the number 0, right? Just send us a Boolean. So that's what it responded back to us, 0 or 1. But then the problem is we didn't know if the LLM was randomly doing it or if there was some good reason behind it. So we added a second variable called reason. So along with the Boolean 1 and 0, we said, okay, also just send us a little description of why you think it is binnable or not binnable. So that's what the LLM did then. It gave us the response we wanted, but it also gave us a reason. And the reason, we didn't do anything with it in our program, but we used it for debugging. So we used the reason to see, is the LLM really doing what we wanted to do, or is it just randomly doing something? So those are all kinds of very neat examples. And that was the next example we were going to show you of furthering the loop, as it were, the workflow loop. And then the third bit of the workflow loop was we wanted to, we asked it to create the code. We created a try catch block, and then we kept feeding the code to itself when there were errors. And when it finally came out without an error, it produced a nice little PNG chart for us. And it produces different charts depending on the column type. So it's very dynamic, and we were not at all involved in its creation. That was the amazing part, right? You feed it a CSV, it runs through the whole loop. At the end, you get a nice little chart from the code it wrote. Not even we didn't write the code. It decided how many bins to make. It decided the range that it was going to use. You know, if it was going to use a chart which is bar or with the line or whatever it was. It labeled the chart correctly as well with the column, the axes, everything it did itself. Gave it the chart a title, and it produced a chart for us, which was so cool.
So once we get that column name and type right, so
Yeah.
I mean, now that we will have a data frame, I mean, would it make sense to limit the LLM calls and do the correlations with those column types that we have with the data frame itself, or even it is recommended to use LLM for that as well?
So LLM can't do math, okay? But with regards to running certain functions, you do the functions, you can do the functions one of two ways. You can either do the function through LLM giving you code, that's always possible. But it requires that loop that I was talking about, that error loop and
Right.
feedback loop. Okay, you have to create the feedback loop. And if that works out for you, then that's great. But the thing about such kind of analysis, right? There is already plenty of static code that does it correctly, right? If you give two numeric columns, ask a correlation, you will get it, right? So there is no need for LLM to generate.
Exactly. Yeah, that's what I meant. Okay.
Yeah. So that I would not use for LLM. But the chart thing was brilliant. Why? Because you remember the trouble we have with making charts, right? I don't know if you made programmatic charts before. You have to decide what the axis name is going to be. You have to decide how many bins. So much decisions are involved in that, right? Human decisions. That is where the LLM really excels, because now you don't need human intervention to do it. It will automatically choose the appropriate items, and it will write the code that will create the appropriate distributions. So that's what it will. I hope you're excited about this. I mean, I'm so excited about this. But I hope you feel, this is something really amazing. You're doing very cutting edge stuff actually. Self-writing code is very cutting edge. So
the concept is nice and the learnings are good, but I think the timing is bad. We are stuck with OPPs and end term coming, and so we cannot put all the interest into something that consumes so much of time at the cost of other subjects also.
Yeah. But one thing I'll tell you, right? If you put on your resume that you've written self-writing code, right? They will bite your hand.
Yes, sir.
They'll be like, wow, we want this person on our team.
I feel good after completion of this project.
Yeah. I mean, both Jivraj and I were so buzzing yesterday because we were just amazed. I mean, we haven't shown, like I said, we haven't shown you the best part yet, right? But it's really something to see it in action.
Yes, sir. This is very different project to do.
Yeah. And so flexible. Once you create it, right?
Yes.
You can throw any data set on it, man. It's just so cool. Any data set you can throw at it, and it will generate something and not die on you. So cool.
Don't lysis.
Yeah.
We have to add it our resume.
Yeah, Himanshu, you have raised your hand. You had a question.
Yeah, that we are asking the LLM to write a code for us, right? So that response will be in a string format. So I'm stuck that how would I extract that code and then run that?
So the code to do that, we can. Anyway, don't worry about that.
Next class.
Next session we'll show you. We'll show you how exactly to do that.
Will it be on Sunday or like next Monday?
No. Sorry. Yeah, Monday. Yeah, I forgot we don't have sessions on Sunday. No. Yeah, Monday it will be.
Monday means 9th of December. Okay.
Yeah.
That's the same doubt. I was thinking about it. LLM produces the Python codes. Then how I run in my project?
Yeah. So there is. So I'll give you a heads up. What you can do is, if you've got a string, okay, any sort of string, the way you can run that code is you use a function called exec, EXEC. Okay. But you have to understand how that function works also. There are some parameters for that function, but you can feed it a string that is pure Python code, and it will run it as if it is your code within your own Python.
So that's why we use UV.
No, UV actually Yes, you're right. That's why we use UE, because that code might have dependencies that you have not written in. So it might import a library like Seaborn or Matplotlib or something, right? So, but when it's trying to import it, it will not be able to get it because you have not pip installed it, right?
Yeah, in that
So
case, we
this,
don't know that for some other data set, it will need some other dependency, right? So,
yes. So what happens is it will pull the dependencies, and UV will automatically get those dependencies, and your code will be able to run. So that's
so,
you're absolutely right. That's why UV is so super useful.
but that dependency should be inside that snippet that we have wrote in the very beginning. That's given in the that project
This
document.
thing, this
No,
thing.
no, 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 no. You with the exec command, it's able to pull those.
Is it? I don't know. Okay, let we'll check and then.
Because
Let's
because
conversation.
when I remember, if I remember correctly, when we wanted to run it, Jivraj, do you remember? I think we didn't import it, right? We didn't import Seaborn or anything, right?
No, but we didn't try it inside the Python file. We just tried it inside the INB and I installed it.
Ah, right. Okay.
So at the first time it gave some error, then I installed it manually.
Because we ran it in the Jupyter notebook, right?
But this is a good question. We need to somehow automatically install those libraries, whatever GPTs we
Yeah.
use.
Yeah. Hmm.
That is the next challenge that we have. Okay.
Yeah. One thing you can do then, there is a easy fix for that. In case you run into that problem, you can restrict the LLM and say, oh, don't use only these libraries.
Yeah,
Don't use
that
any other libraries.
correct.
Maybe all those libraries can be mentioned in the script itself, the metadata script, in inline
Yeah.
metadata script.
Yeah.
So Matplotlib, Seaborn, all those sorting libraries can be mentioned.
Yeah. So that's one way to get around the problem. You can put those libraries you expected to use at the top in that code block, and then when you're sending to the LLM, tell to not use any libraries other than these libraries when it's writing the code. Does that give you some clarity?
Yeah.
Yes, sir.
That's good.
But good question. That was a really good question. Okay, I hope this session was useful. I know it was very long. Shall we call it a wrap then?
Yes.
Okay. Did you guys enjoy today?
We sure did. Yeah.
Okay. At least someone is laughing and smiling, so that's good. That makes me very happy.
Yes, sir.
Yeah. Okay. Great, guys. Thank you very much. So I'll
Thank you.
stop. Yeah. So I'll stop the recording now. And if you've got anything,
Sir, one last question.
Hmm.
How many students are enrolled in this term in TDS?
Technically, there are 1,389 students.
But joining only the maximum 25-20 students.
Yeah, it's very less than that, man. I really
How
wish there were more students on
how
here.
they do, sir?
I don't know, man. I think maybe a lot of them just copy paste or something, which is a shame because they're not learning then, right? These are such fantastic skills.
Yes.
And of course, the other thing is, see, for us TAs to be interested as well, there's got to be interaction, right? If there's no interaction, it's very dull for us as well,
A
right?
lot of people depend on recordings, which
Yeah.
are not actually getting uploaded, which is actually a problem.
Yes.
But most of them are, right. Almost all the TA sessions
I'm
are,
saying in
right?
general, a lot of people depend a lot on recordings.
Okay, yeah. But yeah, I mean, see, today, because we were interacting, we are
Yes.
able to like identify issues we were facing with code. It was very interactive,
How
right?
to solve that issues?
Yeah, because you will encounter these issues, right? So when we see that live happening, then it helps us to deal with those issues as we face them. So, okay.
Should we just one question
Mhm.
on the data? For example, in the age example we take, right?